So we have the problem, and then there were key from the Codeforces around 721 that was connected recently. And so this question statements that we are given an integer and we want to find the maximum value of an integer k such that the relationship this goes to. So we need that as we take the bitwise and from n to the number k in the decreasing order, we get a total of 0. And for the input, we will be giving the number of test inputs, and then we will be giving the the number input itself, and we will have to output the maximum k for each input. So before going to code, let's head down to the logic of this question. So we are given an integer n, and we want to find the maximum k. So for this, let us see the bitwise representation of n. Let the bitwise representation of n be 1 x x x x and some number of x. So for the bitwise n of all the numbers from n to k in the decreasing order to be 0, we need all the bits of numbers from 1 x x x to the number of, to the bitwise representation of k to be 0. One of the at least one of the bits of each placeholder bits to be 0. So the one of the bits at this position and one of the bits at this position, one of the bits at this position, and so on must be 0 for at least one such n. So that is from I equal to k to n. We must get at least one the bit 0 at these places. So what we can do right now is let's say, so as we need all of the bits to go to 0 once, so we must need this bit to go to 0 once, and that cannot happen until we reach at least a point where we have 0 1 1 1 1 with the same number of ones as the number of x's over here. So yeah, once we reach this point, we at least get 1 0 at the first placeholder of the bit, and this will result in the bitwise end of the first bit to be 0, and that was one of the required conditions. So let us check the numbers in between. So at least we must this number must be greater than or equal to 1 0 0 0 0 and so on, and this number is indeed greater than or equal to this number over here. So we can say that this number right here must have appeared somewhere in between of these numbers and can be equal to this number also, but we are sure that this number must have occurred at one of these places. So what we are going to say is that this number 1 1 0 0 0, and this is the number of same number as the number of pixels over here, and 0 1 1 1 which is the number over here must have occurred at least. So let's take the bitwise end of these two numbers. So as we take the bitwise end of these two numbers, we get 0 over here, 0 over here, 0 over here, and so on. So we get the bitwise end of these two numbers equal to 0. So this is the condition required, that we must get bitwise end of all the numbers. So we see that our condition is satisfied at a maximum value of 1 less than 1 followed by a number of bits other than the first one. So we can head on to code stage. So we have n inputs, and we take the number of test inputs as seen in, and then we run a loop for the run case. For the run case, we get an input seen in, and let us copy the test input over here to the end. So we get a long input from the input text file over here, and then we head on to find the maximum k. So initialize k with 0, and then we check how many bits, what is the last, well, what is the highest set bit of that can be checked by. So what we are doing here is that we want to store the number of set bits, number of the order of highest bit of n into num. So each time we divide n by 2, we store we add 1 to num, and that counts the number of order of the number n, and then we output. So this power function basically gives an output of. So so we see we have the required output 1 3 15. So what this is that the number over here is indicative of the number of set bits plus 1, so that's why we had to do minus 1 over here, and this number power of 2 power n minus 1 minus 1 gives the 0111 number that we discussed over here, and this is the number we which will be our answer. So let us check for this. Let us see our. So we see our solution is accepted, and so this was the solution for the